Hello friends, today we'll see the section method of the trusses. Actually, students are unnecessarily having the fear about this method, or they feel that it is little bit difficult. But I feel it is more faster than the joint method. So I'll explain few examples of this section method as well as which basic steps you have to follow, those I'll tell. So in the trusses by section method, first step will be what? The free body diagram. Free body diagram of the truss. Then second, find one reaction. One reaction or one reaction component. And if cantilever type of truss is there, there is no need to find out reaction also. And then after that, take the section. Take the section of the truss. So that cutting plane will cut maximum 3 members only. 3 members only, and truss will be divided into 2 separate parts. It is very important. Means we have to take the section in such a way that that truss will be divided into complete 2 parts. Then after that, either you have to consider LHS or RHS of cutting plane. And then last step is what? Use summation m is equal to 0, summation fx is equal to 0, and summation fy is equal to 0 neatly. That sequence I'll tell while solving the problem only. And if you follow these steps in the section method, then easily you can get the answer by this method, and it is very fast method of solving the truss example. Now we'll see few examples on this. Now we'll see the very first example of section method. The problem is what? Determine the force in the members FE, FC and BC of the truss using method of section. So which are the members? FE means this member, FC and BC, these 3 members are there. And whenever the forces in the members, few members are there, always section method is the best method. Then which are the steps in solving the problems of section method? Those we'll see. So in the solution, very first step is what? You have to draw the free body diagram. Free body diagram means what? Simply, what you are supposed to do? So you have to remove this support. You have to remove these supports. Means at A, hinge support was there. So it is replaced by AY and the reaction AX. So it is A. Means I have replaced the support at A by 2 reaction components, and at D by a single reaction RD, because roller support was there at D. So this is the very first step of the trusses of the solution of the truss by section method. Then in this method again, so this distance is 3 meters. So from this to this it is 3 meters. Then after that, what I have suggested, take the section, and while taking the section you should cut, or before that we'll find out a single reaction. Means now these 3 members are there, so we can get the reaction at D. After free body diagram, reaction at D, how we can get? For the whole truss, you use summation M about A, it is equal to 0. Means this condition we have to use for the whole truss. Then what we'll get? 2.22 into 3 plus 6.66 into 6 minus RD into 9, it is equal to 0, and from this we'll get one reaction, RD. And how we can have it? 2.22 into 3 plus 6.66 into 6 divided by 9, and this is going to be 5.18 kilonewton. Only this one reaction is enough. And once we get this reaction, then after that what we can do? So we can take the section. And how we can take the section? It should cut maximum 3 members only. Means this section will be like this, cutting plane line. So in the graphics we have studied long dash, small dash. So this is what? A section. It is 1, it is 1. Means this truss is cut by a cutting plane 1, 1. And because of this it will be divided into completely 2 parts. Then after that we have to consider the portion which is known, where RD is known. Now you can write RD is equal to 5.18 kilonewton. So this is the force. Means we are going to consider RHS. Then again, so what I'll suggest, if suppose inclined member is there in the truss, get its angle. Now this is 3, this is also 3. Means the angle of this member is 45. Directly we can tell. And whatever the 3 members are there, so it is F, FE, which is asked. This is F, FE. This is F, FC, F, FC, and this is F, BC. These are the 3 members. At the same time, again my suggestion will be what? Consider all these 3 members tensile without thinking. Means tensile means what? Away from this point, away from E, so it is tensile. Away from C, it is tensile. And away from C again, it is tensile. So these are our assumptions. Always you follow this method. If we get the positive answer, that member will be tensile. If we get the negative, it will be compressive one. And now if you see clearly this, no need to draw the additional sketch. Same sketch I am using. Then, so if we consider only RHS portion, means by take the section, so we should write take the section 1, 1 and consider RHS side. Consider right hand side. And now if we observe carefully that right hand side, then it is a non-concurrent force system. So FE, FC and FBC, these are three unknowns. This is known, this is also known. And these uncut members, we don't have to find out anything. So those are balanced one. Then in such situation, always you will find. Now here, if you consider RHS, so as per these three members, two are meeting at C. And if you consider LHS, then those two members out of three will be meeting at F. Similar situation is going to be there. You can consider any side, but here, as RD is known, we have considered right hand side. And then after that, what we have to do? Take the section 1-1 and consider RHS. Then for RHS, we have to take the moment at a point where two unknowns are meeting. Means here what we will be doing? Take summation M about C, where two unknowns are meeting. It is equal to 0. Then how we can solve it? How is the moment about C? Moment of FC and BC is 0. 6.6 is also 0. Moment of FE, it is going to be anti-clockwise, means negative. Minus FE into 3. And the moment of this 5.18 also it is anti-clockwise. Minus 5.18 into 3. It is equal to 0. Means what will happen? FE is equal to minus 5.18. And whenever we are getting the minus sign, that means our direction is wrong. Direction is wrong. Hence, so it is not tensile member. So it is going to be compressive member. Means in the next line, what you have to do? You have to, whatever our assumption of tensile member, it is wrong. And then simply I will write FE is equal to 5.18 kilonewton. And this member is compressive. And see, there I have encircled the wrong direction. I have shown the correct direction. Like this, we'll get one answer. And once we get one answer, the moment condition is enough. After that, we can use summation Fx or summation Fy. Now, FBC is the unknown, FFC is the unknown. One unknown is horizontal. Means the next condition, instead of using summation Fx, you use summation Fy is equal to 0. Summation Fy is equal to 0. If summation Fy is equal to 0, that means what we'll get? FE and BC will not be in the picture. And then what will be there? FFC sin 45. FFC sin 45. It is upward plus its vertical component minus 6.66 and again plus 5.18. It is equal to 0. And from this, we'll get FFC. How we'll get it? (6.66) minus 5.18 divided by sin 45. 2.09. FFC is going to be 2.09 kilo Newton, and it is going to be, so as we got positive answer, so it is the correct direction and it is going to be tensile. It is going to be tensile. And then last condition we are supposed to use is what? Last condition is what? Summation M is there, summation Fy is there. The last condition will be summation Fx is equal to 0. for summation fx, FFE now towards right, FFE is 5.18 minus FBC and minus FFC means 2.09 cos 45. Cos 45, it is equal to 0. And if we make this calculation, again we'll get FBC. We'll get FBC. And that FBC is going to be 3.70. 3.70. Positive answer, it indicates that the assumed direction is right, and that direction is what? Tensile. Means like this, easily with least time we can solve the problem of truss by using section method. Only 3 answers are expected: FE, FC and BC. FC is 5.18 compressive, FC is 2.09 tensile, and FBC is 3.70 tensile. So it is one of the simple way of solving the problem by using section method. Now we'll see the second example of section method. Determine the magnitude and nature of the forces in the members BC, HC, HG. BC, HC and HG. These are the 3 members, correct, of the truss. So either they will mention by using method of section, or even though if forces in very few members are asked, directly use the section method, correct. Then what is the first step of the section method? As I told, so always we have to replace this support at A by a single reaction and support at E by 2 reaction components. Then how? It's a roller support, it is RA. It is RA. And it is the hinge support, it is going to be EX. And it is this is EX, it is EY. So it is what? The free body diagram. It is going to be always first step in case of trusses or in any equilibrium problem. Then if we get or if we are having this free body diagram, at least try to get one of the reaction. Now the members are over here. It is better to get a single reaction component RA. Then what we are supposed to do? Take the moment summation M about E, it is equal to 0. Then what is the moment of RA? About E, RA into 12 minus, it is clockwise, plus minus 12 into 9. 12 into 9 minus 14 into 6 minus 18 into 3. 18 into 3, it is equal to 0. From this, we'll get RA. We'll get RA and make these calculations very fastly. 12 into 9 plus 14 into 6 plus 18 into 3. So whatever the answer is there, divided by 12. 20.5 kilonewton. So 20.5 kilonewton. And our assumed direction is correct, means this is upward, vertically upward, this reaction. So as I told, so first is getting at least one reaction when truss is supported at 2 ends. Then after that, what we have to do? take the section. So where generally these required members will be cut. HG, HC, HG, HC and BC. And as we are going to consider this left hand portion, means RA is known. So I can write this is 20.5 kilonewton. So take the section in this way. Again it is 1, 1. I am taking this line little bit towards right so that more space will be available for showing the direction. Then straight away you consider this is FHG member, FHG tensile. This is FHC, it is also tensile, and this is FBC, it is also tensile. These are the three members. And again here also, so whatever this inclined member is there, straight away we can write its angle 45 because it is 3, it is 3. Means no need to make the calculation also. So directly as I have shown this section 1, 1, now here you can write consider LHS of section 1, 1. Finish. And if you consider section 1, 1, so if you see it neatly, what you will find? So you will find that out of 3 unknown forces, HG, HC and BC, this is BC, this is HC. So 2 are meeting at H. Means a very simple logic. Take the moment summation M about H, it is equal to 0. Then see, those 2 unknowns are meeting at H, means there will not be anything. Then moment of RA about H, it is clockwise, 20.5 into 3. Moment of these 2 forces are moment of 12, it is also 0. It is clockwise and BC is anti-clockwise. Minus FBC. FBC into also 3. It is equal to 0. Means first answer is positive. FBC, our assumed direction is right. Kilonewton. And what will be its nature? Assumed is right, that's why it is tensile. Means one answer we got. Then for second answer, so either we have to use summation fx or fy. Now out of remaining 2 unknowns, one is horizontal, means use its opposite condition, summation fy, it is equal to 0. For summation fy, it is equal to 0. What we'll get? RA is upward, so only left hand side we have to consider. 20.5 upward positive minus 12, only LHS of 1, 1, and these 2 are horizontal, minus FBC, FHC sin 45, it is equal to 0. From this we'll get FHC. Then how we can calculate? 20.5 minus 12 divided by sin 45. It's 12.02. It is 12.02 and it is also tensile. 12.02 kilonewton. We got the positive answer, that means our assumed direction, tensile is right. Tensile is right. So One more thing I'll tell. Out of 3 answers, at least one is going to be compressive always. At least one, sometimes 2 may be there. Means automatically we have got FBC, HC, both are positive, means HG is going to be 100% negative. So let's see what happens. Summation Fx, it is equal to 0. Only these 3 conditions, summation M, summation Fx, summation Fy. We have used 2, now third condition, summation Fx is equal to 0 for LHS side. Then what it will be? FHG towards right, positive. Then FHC is inclined, 12.02 cos 45 towards right, positive, plus BC we have calculated, or we are knowing, plus BC 20.5, it is equal to 0. And now all the plus terms are there, means answer is going to be negative. FHG is going to be, if we make these calculations, we'll get minus 29. Because this value is 8.5, this is 20.5, it is 29 on that side, minus 29. That means this direction, our assumed direction, it is wrong. It should be compressive. It should be compressive. Hence, in the answer, what we have to do? FHG is equal to plus 29 kilonewton and here you have to write compression. So this is the answer, or these are the 3 forces in these members. And if you see how fastly, only with 4 terms, summation M for getting the reaction, then summation M, summation Fx, summation Fy. With these simple steps, without drawing additional sketch, easily we can solve the problem of section method of the trusses. Now we'll see one more example of trusses by section method. Determine the forces in the members AB, AC and DC of the truss by using section method. So this is a very simple cantilever type of truss. We have to get these members. Lower is roller support, upper is hinge support. So without thinking, a very first step in case of any problem of equilibrium is what? So draw the free body diagram. At D there was a roller support, only a single reaction, RD, and at A there was hinge support. We'll have to show these 2 reactions, AX, AY. So it is the free body diagram. And now again, the speciality of the problem of truss, cantilever type of truss by using section method is what? There is no need to find out. There is no need to find out the support reaction also. Then here what maximum we may need. So whatever this member is there, cut member is there, its inclination will need. And that inclination, how we can calculate easily? See, for getting that inclination, means this angle, let's consider it is theta. So this theta will be what? Tan inverse of 1 by 2. Tan inverse of 1 by 2. So 26.56. 26.56. Either directly we'll use this angle while solving the problem. Means if some inclined member is there, so definitely we'll need it. So that's why I have calculated that theta, and straight away we can write also. So this angle and this angle is same. It is 26.56. 0.56. Then, so what is our way of solving the problem? No need to find out the reaction, then directly take the section. Then for taking the section, taking left hand side, it is of no use. Then if I need right hand side, then I'll take the section in this way. Consider this is the section 1, 1. And we have to consider RHS. We have to consider RHS. In the answer itself, you consider RHS of section 1, 1. 1, 1. And as I have told, so all the members initially you consider tensile, and this is also tensile, means away from the points from B and from C. Then, so what is the way? If we consider, so out of these three members, so it is FAB, it is FAB, it is FAC, and this is what? FDC. These three members we have to get. Then how will get? 2 are meeting at C. If 2 are meeting at C, then take the moment about C. Summation M about C, it is equal to 0. It is equal to 0. And the moment about C, so only this right hand side we have to consider. The moment of these two forces is going to be 0. The moment of this FAB is anti-clockwise, moment of 5 is clockwise, means minus FAB into 1 and plus 5 kilonewton, 5 into 1 also, it is equal to 0. So this total is 3, means 3 minus 2, it is going to be 1, its moment is 1. Hence, no need of calculator also. FAB is equal to 5 kilonewton. And here, if we are getting the positive answer, our assumed direction is right. It is tensile. It is tensile. Then second is what? Summation Fy. So because one unknown is horizontal DC, we'll use summation Fy, it is equal to 0. For summation Fy, FAC is inclined. FAC sine 26.56. The vertical component of this. These two are horizontal. And minus 5. It is equal to 0. Means easily we can get this answer. FAC. FAC. It is 5 divided by sine 26.56. 11.18. 11.18 kilonewton. Again, this is also a positive answer, means assumed direction is right, which is tensile. Then the last answer, DC is going to be 100% negative. Well, in advance I'll tell. Summation Fx, it is equal to 0. Then for summation Fx minus FDC. FDC minus FAB, which is 5, and minus AC, which is 11.18, minus 11.18 cos 26.56, it is equal to 0. All the terms are minus, means definitely this answer is going to be negative. (11.18) into cos 26.56, which is 10 plus 5 means it's 15. It is minus 15. Minus 15 means what is the next step? Don't do anything over here. Only we'll have to change this direction. Encircle it. It is wrong. And the correct new direction will be towards C. And this DC, you can write 15 kilonewton. 15 kilonewton. It is compression. Means out of these two answers, at least one is going to be compressive. Sometimes two may be also there compressive. Means answers will not be all tensile or all compressive. This also you can remember. And now see the solution of this problem. A very short one, and very fastly we can solve the problem of section method. Unnecessary in the student's mind, fear is there about the section method. Actually, it is much better than joint method also. Now again we'll see one more example on the section method. Determine the forces in the members AC, BC and BD for the truss by using section method. Now see, so it is also cantilever type of truss. So normally I'll tell, if cantilever type of truss is there, it is going to be more simple. And here both the supports are shown hinge. So what we'll have to do? So first we have to draw the free body diagram. Means you show these reactions EX, EY. Similarly here, so you can show this sides dx and it is dy. This is the free body diagram, very first step. Then after that what we have to do? So we have to take the section in such a way that it should cut only 3 members, and our required members are like that only. So it should cut like this. See, these 3 members are being cut. AC, BC and BD. That is our requirement. That is our requirement. So consider, again this is section 1-1. This is section 1-1 and we are going to consider RHS. So it is going to be tensile. So as I told, it is also tensile and it is also tensile. So that basic thing I have told initially, you assume it. So at the same time, how is it? So it is BD. It is BD, it is BC, and this is AC. Now this is horizontal, these two are inclined. And if you see it neatly, just I'll write the angles also. This angle is going to be 30, which is mentioned. If it is 60, this is also 60. This is also 60. Means we got the angles of these two inclined members also. Now the problem is very simple. So if we consider, say what I'll do. So first step is drawing the free body diagram, cantilever type of truss. No need to get the support reactions. Directly we can get the answer. And for that, summation M you consider, or before that we'll have to write that consider RHS of section 1-1, means whatever that cutting plane line is, section line, we have to consider RHS portion. Then you take the moment about the point where two unknowns are acting, and that point is B. Summation M about B, it is equal to 0. Then about B, so what is going to be the moment? So here we need to make few calculations, and for that, so what we need, so from this, if you drop this perpendicular FBC, means for taking the moment about B, we need this distance also and we need this distance also. See, the moment of the forces BD, BC, it is 0. Oh, only there will be a moment of 1000, and for that, out of this 10, how much distance, that we have to calculate. And how we can calculate it? So now, what we are knowing, this vertical distance, let us consider this point is M. This point is M, and for taking the moment, we need AM. Then this AM distance, how we can calculate? So this total AC is 10. Total AC is 10. It is 90. This angle is 90. Means if it is 10, so this is going to be 5. This is BC is going to be 5. And BC is 5. Then CM we can calculate. So this CM divided by this 5. So in this right angle triangle BMC, CM divided by BC, which is 5, it is equal to cos 60. Hence CM is going to be, so these distances will need, CM is going to be 5 cos 60, 5 into cos 60, it is 2.5 meter. Means this remaining AM is going to be 7.5. Similarly, what is BM? BM by 5 is equal to sin 60. Hence, BM is going to be, so only this is typical part in this problem, 5 into sin 60. It is 4.33 meter, and this will need while calculating the moment. Now see it. So how will get the moment of about B? The moment of BD, BC is 0. Moment of this 1000 is 0. So this will not be in the picture. This 1000 will be what? Clockwise. 1000 into, actually that distance is MA. MA is 10 minus 2.5, which is CM. Means 7.5. So this is the moment of this 1000, and moment of this FAC is going to be anti-clockwise, minus FAC into 4.33, that BM distance which we have calculated, 4.33, it is equal to 0, and we'll get this positive answer. Means this member is tensile, FAC is equal to 7.5 into 1000, 7500 divided by 4.33. 1732.10 Newton. So this is the force in AC member, and it is going to be tensile. One answer we got. Now, how to get other two answers? For getting other two answers, we have to use summation fx, summation fy. Then, if we use summation fx, summation fy, it will be vertical. Means it is also inclined, means both the members will be there. Then in this case, what I'll suggest, So the best way is what? Just see. So it is the excellent example. So what? If this angle is 30, it is vertical, it is horizontal, means this angle is going to be how much? 60. And if it is 60, now what I'll do? So I'll consider this AD line as x-axis, and I'll consider this as y-axis. This as y-axis. As per this problem is concerned, means problem will be solved easily, because out of BD and BC, one unknown will be along x-axis. Change the axis and then use this condition. Now if unknown is along x-axis, again you use summation Fy. Summation Fy is equal to 0. For summation Fy, BD, that we don't have to consider. We don't have to consider, and see that if this angle is 60, this angle with x-axis is also 60. It is also 60. Then for summation Fy, one thing, so it is going to be along y-axis, means minus FBC minus 1000 sin 60. It is also its component along y-axis, minus 1000 sin 60. It is equal to 0. Only this member, and this, it is there. It is along x-axis, and so this member is also there. So this AC we have calculated. Its sign is also negative, minus 1732.10 sin 30. It is equal to 0. Means this FBC is going to be negative 100%, and that answer will be into sin 30 plus 2000 into 2598.10 minus 2598.10. That means, so whatever this BC is there, this direction is wrong. It's not tensile, it is compressive. Hence, FBC is going to be 2598.10 Newton, and it is compression. It is compression. And then finally, summation Fx is equal to 0. For summation Fx, see, this is the x direction. If we consider this is positive, let us consider this is negative. It is negative, means minus FBD. Then see that it is perpendicular to it. No need to consider this in Fx, but it is towards right, and it is towards left. So as per 1000 is concerned, it is towards right, plus 1000 cos 60 plus 1000 cos 1000 cos 60, means it is towards right, This is also towards right, it is perpendicular, it is towards left, it is towards left. Minus AC. AC means 1732.10 cos 30. It is equal to 0. Then from this, what we'll get? 2000 into cos 60 means it is 1000. So 1732.10 into cos 30. It is 1500 minus, so it is plus, then it is minus 1000 means 500, and answer will be minus 500. FBD will be minus 500, and if it is minus, that means again this direction is also wrong. So comparative is correct. Hence FBD is going to be 500 Newton, and it is comparative. Means like this, any problem, let it be tough also, easily we can solve with these 3 steps by section method. So I feel section method is one of the best method to solve the problems of truss. Thank you.